Hi everybody, this is lesson 4.5. I returned to proportional reasoning. This is the last lesson in chapter 4, modulus 4. Let's read the specific objectives. Students will understand that proportional relationships are based on constant ratio. Rules for solving equations can be applied in unfamiliar situations. Students will be able to set up proportion based on contextual situation and solve proportion using algebraic methods. Last lesson, 4.4, we have done some equation solving. Today we'll see another familiar lesson for many of you, which deals with proportions. We'll also be able to make some connections to the previous modulus and previous lessons that we covered. So let's look at the problem situation number 1, changing shape. You've been hired to do public relations for a country of Greenland. You'll put together a brochure that will be several pages, but on the front page you would like to have the Greenland flag as big as will fit on the page, and the page is 8.5 by 11, standard printing page, and you have a file in which you have the small version of the flag, which is red and white and seen below. I also transfer it to Microsoft Word so we can work with this. So that has a size of 1.5 inches in length and 1 inches in height. Question number 1. What would be the dimensions of the extended image if we want the flag to be as large as possible in its horizontal position, given that there must be 1 inch wide border around the edge of the brochure? Now, the margin is actually something that's standard in Microsoft Word document. By default, is that it has 1 inch margins already. So I'm kind of going to draw it right here. This is a standard page. We already have margins from each side like that. They are 1 inch in size. So when you're printing a standard page, then all of these are going to be 1 inches. 1, 1, 1, and 1, and the rest is printable area. So we got this flag, which is 1.5 by 1, and we want to extend it in such a way that it fit entire printed area without distorting the image in any way. So it stays the same. So So how are we going to approach it? Well, first we need to know sort of what are we working with. Well, this right here is 11 inches. This right here is 8.5. So let me ask you this. If we remove the margins, what would be the width of this printable area now? If you subtract 1/8 margin on each side, what would it be? I'll give you a moment. All right, so we subtract 1 inch from each side, so it's going to become 6.5. 1 inch on the right and 1 inch on the left. Okay, now let me ask you, what about this printable size? How much is that? All right, I'll give you a moment. Yeah, so you subtract 1, so it's 9 inches. All right, so why don't we just extend that Greenland's flag to be that 6 by 5 in width and 9 in the height. Let's see what's going to happen. Okay, so I'm going to take this. I'm going to go to the image. All right, let me click on this. And where we have a picture format, I'm going to switch. You might not see I might zoom out. But anyway, I'm entering the dimensions. So putting in the numbers, which are 9 inches in height. So I'm going to change this to 9. And I'll put this over here. Let me not lock the ratio. So I don't want to lock the ratio. Actually, I want to keep it like this. So 9 is here. And then absolute width is going to be, what was it? It was 8.5. And then you subtract 2. So it's going to be 6.5. 6.5. All right, so let's see what we got. So how do you like it? Does that look good? Did we do a good job? it fit in the region right here, well, we get fired. We absolutely get fired. Like, what did we do to the green flag? Instead of circle, we got an oval. All right, so that was not good. Okay, so let me bring it back. Here we go. So we did not do a good job. So how much should we extend it to preserve its dimension? That means we need to do some mathematics, correct? So what do? Well, we want to make sure that it stays within the same ratio. All right, so we want the ratio to be preserved. Now, to preserve the ratio, we're going to be doing this. So we're going to put that, so this is what? This is the length. Well, we call this the width, and this is the height. So in order for the for this to be preserved in terms of the ratio, notice that this one is a longer height. It's a longer side. So we are limited by the amount of space that we got here. All right, so we can make it more than 6.5 inches wide. And then in terms of the height, we have more flexibility because the height is smaller. All right, so we can make height to be 9 because then the wood should be more than 9 and we don't have that space. 6.5 inches is the most that we have in the wide dimension. So that's why we're going to try to do this. So we're going to put it like this. So we have height over width. So right now it has a dimension that the height is 1 inch and the width is 1.5. So that's the original. All right, so we want to enlarge it so that the width becomes 6.5 because that's the space that we have. And my question to you, what should this be? All right, I'll give you a moment to see if you can figure it out. And I'll give you some options that you could choose. All right, so let's review. This would be basically the main focus of this lesson, is how to go from this original one to another one by preserving the dimension. So it has the same kind of shape. So the circle stays a circle and the whole shape appears the same way. We're just enlarging it. Okay, and the mathematics here is, how do you make this bigger? Well, if you go from 1.5 to 6.5, how many times bigger do you make it? You're not going to add 4 to the numerator and denominator. You can try it, but you will also see that the image is still not preserved. So what we could do, we can go ahead and divide 6.5 by 1.5 and see how many times larger we're making it. So we're going to do this on a calculator. So it becomes 4.333, and it's repeating. So that's how much bigger you're making this image to be, 4.33 times. And whatever you do it to the denominator, you should also do to the numerator. You should enlarge the height also to be 4.333 times bigger. And 1 times 4.333 will give us 4.333 of an inch. All right, now check this out. Let's go to Microsoft Word and let's click on options. So where do we have this? Picture format. And one moment, let me just pull up. Okay, so we said that the absolute dimensions here, it should be 4.333, correct? That's the height. 4.333. Well, this one should be 6.5. 6.5. Okay. All right, now we did a better job. Yeah, it's a little pixelated because I chose an image that's quality-wise is not the best. But if you compare this with the original, you could see that the image is preserved, right? So if you go back like this and like that, you could see that the image has been preserved and it fits exactly the margin area. So we still have an inch left on that case. So you see, now Microsoft Word has it built in, so it basically can lock the ratio. So if I click on, if I go here and I click right here to lock the ratio, then what I could do, I can actually move it like that where it will keep the image preserved. Okay, it's built in any you know, editor, including most, all of the softwares that you use to work with the images. So the idea of the aspect ratio is there. Now the thing here, the term that we use, the artists use, the photographers, and in mathematics, we use the term ratio to describe something that will keep things consistent. So question number 2 is asking what must be true of a new set of dimensions so that the precise shape of the image is preserved. Well, that means that the ratio of dimensions must be the same. So if you look at this right here, if you look at the ratio of, let's say, height to the width, 1 over 1.5, it's the same thing what would happen if you take the image 4.33 and you divide it by 6.5. The ratio would be about, if we put this on the calculator, 1 divided by 1.5 is about 0.666. It's actually going to be 2/3. And this one is also going to be 2/3. So the ratio is 2 to 3. So that's something that will stay consistent. Not only you can do the ratio of height to the width, you can also do the ratio of, let's say, width to the height. It's this idea that the ratio of the dimension has to be the same. So notice here, the original image had a ratio of 1.5 to 1, which equals to 1.5. This is the original one. While the one that is enlarged has the same ratio. 6.5 divided by 4.33 will also give you 1.5. It just means that the width is 1.5 times the height. So that's why we say that the aspect ratio is preserved. Okay, well, the other way that we can also address this question is by introducing a proportion. Okay, that might have you, when I asked the question originally, what should be that image be? You might have recognized this question as a proportion question. So if you, what's important when you set up the proportion is that you keep the your dimension consistent. So if it was 1 over 1.5, right, and then you want the width to be 6.5, you want to make sure that these are consistent, right? So you talk about the width in the denominator, you want to set it up like that, and then you put for the numerator an unknown, an x. Remember that? And that becomes a proportion. You just have to make sure that there's a consistency, that you have height divided by the width and not other way around. Okay, and then you can multiply. One moment. There we go. I just want to make sure that I was recording. Okay, so then you're going to go ahead and cross multiply like this. So you got 1.5x equal to 6.5. Okay, so when we have an equality of two fractions, the cross product must be equal. And then you divide both sides by 1.5. Which is, by the way, something that we did already earlier. Over here, you see. You get an answer of 4.33. It's not exact, but, you know, the idea here is you are setting up that as a proportion. Okay, so what's important again is that when you're setting up a proportion, you keep the ratio consistent. So let's look at question number 3. Your graphic artist hired to make a billboard for a college. The original logo is 2 1/4 inches in height and 3 3/8 inches in length. You need to enlarge it to a length of 6 feet. What will be the height of the enlarged version? Again, things simple. We have 2 dimensions. One of them they're talking about the height, and the other one is talking about the length. So, write the height. Let me just use a regular color here. The height, and you write the length. Write that as a fraction, like this. Put a colon, and then you want to set up a proportion, equality of 2 fractions. So the original logo is 2 1/4 inches. So what is 2 1/4? 2 1/4. A quarter is 1 over 4. We're going to write it as a decimal. It's an inch. And the height is 3 3/8. 3 3/8. I write it as a decimal. So it's 3 point, and then divide 3 by 8. So that gives us 3 divided by 8 is 0.375. Don't get thrown off of the fraction. You got this. Notice, you see how this is in inches and this is in inches? They actually cancel out, and the ratio just tells us that the length has to be related to the height, so that the fraction that forms is the ratio of 225 to 3.375. We can actually divide those two numbers to get what that decimal is, but the idea is that it has to stay consistent. So now we're enlarging so that its length is 6 feet. Notice there's a different units being used, and in this chapter we did talk about units at the beginning a lot. Now, when it comes to ratios, it doesn't really matter what are the units within each fraction as long as they're consistent. So for instance, the question is asking what is the enlarged height? As long as it's measured in feet, then feet and feet will cancel. The ratio itself is unitless. So it doesn't really matter what the units are, as long as they're consistent within the same fraction. And this is going to be the x. Alrighty, and then I'll give you a moment to solve for x, just using the technique that was introduced a moment ago. Go ahead. Alright, so let's review. We're going to multiply, cross multiply, like this, and we get 3.375x equal to 2.25 times 6, and 2.25 times 6 gives us 13.5. All right, and then we divide both sides by 3.375. So then we get x equals to 13.5 divided by 3.375. That gives you exactly 4, and the units will be the same, 4 feet. And you got this. You see, not too bad. So you just need to set up the ratios. Now let's make connection to something that we did before. Remember the Maria and Bruce who worked in the corporation that makes video games? Maria is making $40 per hour. Bruce works in a mailroom, $15 per hour. Well, actually, we didn't have that particular setting. We remember we had Maria who weren't happy about the salary, and then we calculated to see that her relative increase in salary was not as large as the others, so that's why I remembered them. But anyway, this is a different setting. So Maria is making $40 per hour, Bruce is making $15 per hour. The company made record profits last year, and the CEO had decided to give the employees a raise. If Bruce gets raised to $40 per hour, what would be a fair new rate for Maria? Well, the way you can calculate this, you can, just to remind you, right, we can do this. He was making 15, and now it was raised to 20, right? So we can calculate the relative change. Remember, subtract and divide it by the original. So it's 5 over 15, 5 divided by 15, and that's about 33%. Repeating, so it's about 33%. So then Maria was making $40, so her salary should also increase by 33 and 3%. So we can take $40 and we can multiply it by 1.333. Again, I'm touching the 1, assuming that you're getting a little bit more comfortable understanding. If something goes up by 1%, if you touch the 1, then it gets you back what you started with, an additional 33%. So that should be, $53.32 about. So that's the way we would have done it before. I did it quickly just because, it's meant to be a review for percent increase. Now let me do it slowly by describing this as proportion, okay? So the proportion of salary can be like this. New over old should stay the same. Or Maria divided by the Bruce salary should stay consistent. So it can be done either way. So look, one way we can say new to old. So we got Bruce and we got Maria. So here, his salary went from 15 to 20. So new is 20, old is 15. And it should be consistent with Maria's, which was old to be 40 and new would be an X. Go ahead and solve this proportional. I'll give you a moment. All right, so let's review. 15x equals to 20 times 40 is 800. Divide both sides by 15, and we get the same answer as before. Let's double check. $53.33. A little bit off by rounding. This is more precise because this one is, we didn't round anywhere until the end, but the answers are pretty similar. Okay, so it's $53.33. So that's one way you can set it up. And the other way you can set it up, as Maria's salary over the Bruce salary should be the same. Let me write it over here. So Maria's salary divided by the Bruce salary should be the same. So Maria's salary, and we have old and we have new. Okay, so the Maria's salary was what? It was $40. And his salary was $15. His salary raised to $20. The key of the proportion is consistency. Whatever you put in the denominator and the numerator has to be consistent. So if you're talking about Bruce's salary in the denominator, it should stay in the denominator. You're talking about Maria in the numerator, leave it in the numerator. You can flip it. So Bruce is in the numerator and Maria is in the denominator. That's also going to be okay as long as you are consistent. So that would be the x. And then notice you get the same equation. 15x equals to 800, which gives you back 53.33. All right. So the key here is consistency. All right. And we say that things are proportional in that case. All right, so the increase is proportional, meaning it is subject to the same rate. Jen is a VP in change of accounting, making $120,000 per year. What should Jen's new salary be? So same idea. We're gonna take either Bruce or Maria. Let's use Bruce's salary. So we say new to old. We got Bruce and we got Jen. Okay, so his new salary is 20. His old salary was 15. Jen's salary was 120. What's the new salary going to be? An X. So it's the same percent increase, also 33% increase. You can do it like that as well. Notice that 20 divided by 15 is 1.33. That does demonstrate the 33% increase in Bruce's salary. But again, for consistency, we leave it as a fraction. And then we can go ahead and cross multiply. So we got 15x equals to 20 times 120,000. Large numbers, but that's okay. So 20 times 120. I use the calculator, even though I do not need to. 240. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 all together. So it's 2,400,000 equal to 15x. Divide both sides by 15. 15 is still, 2,400,000 is still on my calculator, so I'm dividing by 15, and you say her salary should be 160,000 per year, given that percent increase. What does it mean to be proportional? The ratio of variables must be the same. Okay, so proportional means that the two rates are equal. So proportional means equal rates. And I think this is sufficient. So I don't want to go any further. I want you to practice on equations and proportions and understand this concept of proportionality. Make sure you also complete the homework for that lesson. Here it is. We are done.